Good afternoon, Dr. Dekha, Mr. Singhal, and dear participants. So we will start this session now. The topic is Total Quality Management. It is shortly called TQM. TQM, Total Quality Management. So the first question comes to our mind is, what is quality? Quality. Quality is a very famous word. It is applicable to almost everything in our life, in any product, to any service. So in every cases you will heard this name quality. So common is a name, and so common is a name that it is total quality management. It seems it is very easy to understand, but in view of the modern management, there are many things we have to go deeper into this subject. So I want to introduce just few things about this subject today, and you have to relate it to your own field, and then we will be finding many more applicable cases there, and it can be discussed later in between you, in between us, or in between your staffs also. So let's go to this very shortly. So what is quality? Quality is a degree of excellence to fit the implied need of a product or service. So it may be product, it may be a service. So the quality word may be entangled with the product and service. Then this is a product, this is a service, this is a what is this? This is a construction going on. It is Subansiri project construction site. There is also it will come quality of the project. So quality is that. And what is management? Management is nothing but a structured approach. It is a structured approach to continuous improvement in quality, processes, and performance. So management covers two other words, processes and performance, which is not covered by quality. So we will go to all these things today. Now let us discuss what are the dimensions of quality. What are the dimensions? The quality have these dimensions. The quality may be related to design. The quality may be related to planning of the thing related to the design. It may be related to the conformance to the design after somebody has developed a product, whether it is conformed with the previous planning or not. It may be related to that. So it is important to know that in relation to design, these two dimensions may come. And other two dimensions, it is utilization of conditions and post-installation service. It comes in the process domain. So there are two domains, so design and processes basically, and utilization of conditions. What is utilization of conditions? It is necessity of beneficiary information using manuals, helplines, and personnel trainings. That means in total quality management, we are entangling everybody from the planner to beneficiary. This point is important here. The planner to beneficiary, everybody will be entangled in this process. And then post-installation service. This is putting a system for monitoring and assessment and development. So you are introducing a service somewhere, introducing a construction, introducing a any type of service. So after that, what is happening to it? How are it meaningful? What is it feedback? How it can be further developed? These things also comes to these aspects or domain. So these are the dimensions of quality. Quality control techniques for planners. So what will be the basic duty of our planners regarding quality control? It is quality control techniques are specific activities and procedures adopted and designed by planners and senior personnel. So regarding the quality control, we have to design what will be our activities, what will be our procedures. This comes first in quality control techniques. Quality control techniques are actually three types, three techniques are included. Quality of service, source, quality at source, quality control tools, and acceptance sampling. So in the later slides it will be more clear for you. So the techniques include criteria to be adopted. So in these techniques, we have to clear what will be our criteria, what will be our procedures, what will be our interpretation, how to interpret. So these are important. What things should be in the criteria, what should be in the procedure, and what should be our mode of interpretation. These are also important. So what is TQM? Now we are coming to TQM, Total Quality Management. The definition says that it is a structured approach to continuous improvement in quality, process and performance, as we have already discussed. Quality, processes and performance. So now the main question is why TQM matters in flood control and erosion management. So to answer this, we can take help of these few points. It ensures high quality, resilient and sustainable infrastructure. It reduces risk of project failures and environmental damage. It enhances stakeholders' trust through improved service delivery. And it aligns with the modern management concepts like Agile, Lean and Six Sigma. These are modern management concepts. So it will lead to total quality management. If we notice total quality management, it will lead us to these modern management thoughts. We will get it in the later slides. So key principles of TQM with modern theories. These are the principles, main principles. Customer focus. We must deal with the customer. We are engineer, we are planner, but we always have to be aware that we should deal with our customer. Customer means maybe they are a community people. Continuous improvement is a goal, is a principle of TQM. Continuous improvement. So it is developed. Have you heard about Kaizen? Kaizen, it is a Japanese word. It's continuous, its meaning is continuous improvement. Japanese people are very much aware about the quality and aware about their production processes and aware about their jobs. So most of the early theory was developed in Japan regarding this quality management. So we will get it in the next slide also. So Kaizen is a principle which actually we can apply in our life also. Continuous improvement. So beautiful, nice word, continuous improvement. Who does not want continuous improvement? Everybody does. Everybody need it, continuous improvement. So in case of our dam, in case of our erosion work, in case of our construction work also, there is this part, the continuous improvement. So Kaizen is related to this. Then there are another principle for standardizing the construction and maintenance and monitoring. Then again, total employees involvement. Quality cannot be preserved by only a few staff. It should be preserved by total employees related to these projects. So you have to make them involved. So training of the engineers and training of the field staff, involvement, their involvement is very important in total quality management. And another principle is fact-based decision making using data and technology in flood forecasting and mitigation. So there are very important aspects are you have to take feedbacks from other people to develop your projects and to make it of a better quality. An integrated system, it is a key principles. So coordination between different departments and agencies. This is another important principle of TQM. TQM in technical operations. Some advanced techniques you may apply in TQM. The advanced techniques related to quality planning, it is identifying the standards of embankment, drainage systems and erosion control structures and compliance with national and international environmental safety norms and risk-based thinking, smart infrastructure planning with GIS and AI. These are included in quality planning. Then quality control and assurance in projects. You can use GIS, remote sensing, modeling tools for precise data. And material testings and audits in dams and levees construction you can use. And performance monitoring through IoT, Internet of Things, and sensor-based flood warning systems. These are the modern tools you can use in the TQM. Then we are coming to preventive and corrective actions with digital integration. Regular inspections of embankment, river banks and drainage channels. It's very common. Predictive maintenance using AI-powered analysis. It can be done in present days. Post-project evaluation and lessons learned. Automated drones and satellite imaging for real-time erosion assessment. Engaging local communities for sustainable erosion control practices. And crowdsourced monitoring via mobile applications. These are the digital integration with total quality management. Now, what are the challenges in implementing TQM and strategic solutions? Some common issues are resistance to change among employees. Our people like to do a work in similar manner. They do not want to change. Most of us are like that. So there is another subject you have to introduce, that how you will overcome that resistance to change among employees. This is a common issue. In any case, you will find that whenever you are introducing change, there are resistance, there are prevention. So how you will overcome this challenge? And then lack of awareness of quality processes. I think it is also a common issue, because we know that quality, yes, do you know about quality? Yes, I know about quality. But there are lack of awareness regarding the minute details of how to do it. So up until now, it is basically most theoretical. But when you go to its practical side, then you will perhaps realize that how important it is. Now we are going slowly through it. Then budget constraints affecting quality implementation. Our budget planners also, in many cases, they are also not interested in these types of things. There are constraints in the budget mostly for our quality management systems. Then bureaucratic hurdles, similar thing, and multi-agency coordination issues. It is there. Whenever you do something regarding quality management, you will have to coordinate between different departments and different persons. Then you will face this difficulty, bureaucratic hurdles and multi-agency coordination issues. Then, so other challenges are conducting regular training and awareness programs, using cost-effective yet high-quality materials, encouraging a culture of accountability and feedback, leveraging digital solutions for real-time quality assessment. How it can be tackled? Another point is case studies and global, looking to the global best practices. What other people are doing regarding this? What our case study is pointing out? Are we, do we know what our case studies are telling us? So we have to study these things. So case studies and global best practices can be applied to, realize TQM. In Netherlands, they are doing this IoT-enabled levies with AI-powered analytics. They are doing these things. It is given in the extra text provided to your group. And in Japan, geoengineering and satellite imaging for erosion control, they are doing it. You can read further in the internet. And in Australia, they are using blockchain for transparent water governance. Have you heard about blockchain? Definitely, many people have heard about it. Blockchain is related to cryptocurrency. How cryptocurrency is generated, how it runs, how it functions. If you want to understand it, then you have to understand blockchain. And they are using blockchain to water management. And blockchain is a, do you know ledger, accounting ledger? Have you heard about it? Ledger. So it is a ledger technique, basically blockchain. But these blockchain, they are applied to the water governance. It is almost difficult to understand, but they are doing it. So people are not staying at the same place. So it is difficult. That is why it is difficult, because it is so common, but it is not common. So our engineers and our planners must be aware of these things. We will get some more things in the next slides. Another thing is, important thing is cost of quality. In anything, if anything you are doing, there is a cost. Is not it? There is a cost. So what do you mean by cost of quality? Cost of quality is cost of poor quality. How much expenditure you are making due to your poor quality? How much expenditure you are making in non-maintaining your quality or maintaining your quality? Are we aware about that? We shall ask ourselves whether we know what are the costs we are incurring due to the good quality or due to bad quality. So this is the cost of quality. It is an important concept, and this concept includes two components of cost of quality. There are two components. One is cost of good quality, the test of activities to ensure a product or service meets quality standards before it reaches to the customers or beneficiary. And another is cost of poor quality. What are the cost of developing poor quality works? So these two are the component of cost of quality. So there is cost of quality equation. It is cost of quality is equal to cost of good quality and cost of poor quality. So in cost of good quality, there are two components, prevention cost and appraisal cost. So what is prevention cost? Whatever cost you are incurring due to prevent a failure, that is prevention cost. And appraisal cost, what cost you are incurring for appraising the reason of failure to you from the field level to you. That is the cost of appraisal cost. Then cost of COPQ, it includes internal failure cost and external failure cost. Internal failure cost is related to failure related issues related to your internal management, and failure related cost related to your external relationship or external aspects. It is external failure cost. Here is an example of COQ, cost of producing, shipping, handling, defective products, wasted times, resources, money associated with procedures and handling defective products, and lost opportunities or revenue due to subpar products or services. So this kind of cost we are incurring, it will come under cost of quality. Next, we will discuss some TQM philosophies and approaches. You may find it non-interesting because this is purely theoretical. I know it. But I think we must go to theory. We must go to theory. We cannot solve it by our imagination only. We have to think what others are thinking, what others are developing, what is the development in the field. So I think it is important. So, okay, please bear with me. So, some TQM philosophies. TQM is not modern concept. It is not modern. It is actually in 1947, 1951, it is developed. So there are important philosophies. These TQM gurus, there are some TQM gurus in the management science. You will often heard their name. They develop some philosophies about quality. They are developing some philosophies regarding total quality management. So one of important thing is Deming wheel. Deming wheel. Another is Juran's quality trilogy. Another is Crosby's absolutes of quality. Another is Taguchi's quality loss function. We'll put some details in the later slides. So these are famous quality gurus. Deming, Juran, Crosby, and also there are some important names are there. So this is Deming wheel. Deming was an engineer. He was appointed in Japan, perhaps in 1951. This Deming wheel, he has made many philosophical development regarding quality control. And finally, this is the summation of that it is Deming cycle. It is also called Deming wheel. Check, act, plan, do. Plan, you plan the thing, whatever is in your hand. You do it, then you shake it, then act. This is Deming wheel. So only it can lead you to continuous development. And it is related to our life also. We have to plan anything. We have to plan our career. We have to do. We have to seek. And we have to act. So it is very famous. It is plan, do, seek, act. PDCA. Deming. And Juran's quality trilogy. Juran is a Romanian engineer. Worked in America. He is very famous for his trilogy. The three principles at the bottom is based on planning, control, and improvement. Almost similar thing, but approach is somewhat different. Joseph Moses Juran. And another important philosopher is Crosby. Crosby, absolutes of quality. What he said, Crosby, quality is defined as conformance to requirement, not as goodness or elegance. Actually, in case of quality, there are different thoughts. So Crosby was the first person who told that there can be no goodness or no elegance or no steps in between. There can be only zero defect, or there cannot be close enough. There can be product defective or zero defect. There cannot be any good enough or in between perceptions. So Crosby's absolutes of quality tells us like this. Here's another important and very interesting Tagus's quality loss function. Tagus's quality loss function gives us how we can calculate our loss. How we can calculate our loss due to non-qualitative services and goods. Taguchi is also a Japanese engineer and statistician. So he has developed this equation by which we can find out what is the loss due to poor quality. Then we are coming to the quality control tools used in TQM. Quality control tools. So these are the quality control tools. So these things we have to use by our hand. So we are coming from the most theoretical parts to some practical instruments. These are the tools. One is flow chart. You have heard about it, flow chart. Another is check sheet. Another is histogram. We will give some in next slide. We will give elaborate it. Histogram, Pareto analysis, scatter diagram, control charts, cause and effect diagram. These are the tools for maintenance of quality. So this is a flow chart. You have seen this kind of flow chart. This is a flow chart. Suppose you are going to develop a new product, then you have to first brainstorm, then develop the new product. And for developing the new product, you have to make the prototype. If the prototype is there, if your opinion is yes, then you can design it. If your opinion regarding to the prototype is no, then you should refine it. And if your opinion regarding the refinement is no, the design is after design, you should test it. And if the testing result is no, then you have to refine it. Then you have to again design it, again test it. Then if you test and your result is yes, then you can produce it. Then you can launch it to the market. So these are the steps shown by this flow chart. So this flow charting method is useful in many works. This is a check sheet. Check sheet is regarding recording of some, suppose you are recording defect. or difficulties. Wrong orders. How many wrong orders are there in Monday? How many wrong orders are there in Tuesday? How many wrong orders are there in Wednesday? Similarly, suppose shipping damage. In Saturday, you have observed this much damages, shipping damage. On Monday, shipping damage is 0. So you can track like this. Through this, you can track how many disadvantageous conditions are appearing day by day in your job or service. It can be done by 6 sheet. It is a histogram, you know it. Histogram, it's useful. This is Pareto analysis. This is very important concept. Pareto analysis. Vilfredo Pareto was an Italian. Vilfredo Pareto. Have you heard about it? Vilfredo Pareto. His principle is related to our life also. He says that you just see the diagram. So, it is regarding to a medication error. It is a case study regarding to medication error. Dose missed 92. These are the factors. Dose missed, wrong time, wrong drug, overdose. These are the factors. You have to arrange it like this, from greater to smaller. Then this curve will give you that these 20% of the factors is responsible for 80% of your result. These 20% are vital few. These are the vital few. These 20% of the factors, 20% of all those factors is responsible for 80% of the results. 80% of the results. So this is a very important philosophical development by Pareto. Here, I am giving some important example in the later slides. So we have to just remember it. I remember it always. Because in case of a student also, if you see what are the factors affecting him, you will see that 20% of the factors is affecting 80% of the result. It is always true. It is miraculous, but it is always true. So Pareto's analysis is very important. We will come to the next slide for this example. This is scatter diagram. In scatter diagram, you will plot data of two variables, and you can say that it is how is their relationship between the two variables. If the relationship is growing in a similar way, then it is positive correlation. If one is increasing, another is decreasing, then it is negative. Then there can be curved correlation, and there can be perfect correlation. One is increasing, another is also increasing. So this is none. Degree of correlation is none. None means there is no correlation. So these are also applied in quality management. Let us see how it will be applied in some cases. Control charts is also an important tool. In control charts, what they are giving, there is a mean, and you will have to observe what is your result. If it is very much deviated from the mean, then you can throw it out. If it is nearer to the mean, you can accept. So in any study, you can observe something, and if you plot it, that if it is nearer to the mean, then you will say that these are acceptable, but these are not acceptable. So you can filter something out by this control charts. This is another important TQM tool. It is Ishikawa fishbone diagram. Ishikawa is also a Japanese person. Almost he is a philosopher regarding this. This is fishbone diagram. You have got it perhaps. Fishbone diagram. We can find out cause and effect relationship. If we have a problem, the problem is affected by what? What things are causing this problem? Maybe people causing the problem. Maybe our process is causing the problem. Maybe our equipment is causing the problem. Maybe our material is causing the problem. Maybe our environment is causing the problem. Maybe our management is causing the problem. And in case of the different categories, suppose in equipments also, there may be some subcategories. So these things related to the equipment is affecting the problem. These things related to the process is affecting the problem. These things related to people related thing is affecting our problem. So this kind of analysis can be done by this Ishikawa fishbone diagram. So this is a theoretical development regarding this. Then actually we have to discuss before the conclusion. Do you think these tools can be applied to your works somehow? Do you have any idea?
We are unable to correlate. What you told quite
out of context. Actually, total quality management relates to the modern management, and it is to the products mainly. But in case of construction and erosion also it can be applied. So this is theoretical, although let me take some time. It is somewhat practical. Suppose this is Pareto chart. Okay, this is Pareto chart. How can you apply it in your case? Suppose there is a contractor A, contractor B, contractor C, contractor D, contractor E, F. Suppose you are finding out that in case of contractor A, this much 92 numbers of failures or quality issues has happened. In case of contractor B, 83 numbers of quality issues have happened. In case of contractor C, 76 numbers of quality issues has happened. Suppose you arrange it in the descending order, then you will find that your 80% of your defects, these are the defects, these are the total defects, these are coming from this ABCD, this numbers of contractors. Then you can eliminate the 4 contractors from your job. Suppose you are, again I am saying, you are engaging some contractors, you are taking some materials from them, and you are getting some defective products, defective supply. Okay, it's most practical, but you have to eliminate. You have to, how you will sort out that this is he is a bad contractor, this is a good contractor, or I have to accept him or not. So this by this tool, it looks simpler, but it will say that you eliminate this ABCD, then you will get rid of 80% of your problem, and the remaining problems you can solve it. Suppose 53 numbers of uh, defect you can accept, and you remove these conductors by a simple Pareto search.
Is it possible to remove
Contractors. It is possible because your report is valuable. Your field, suppose you are in the field, your report is valuable. In suppose you are in the planning level, tomorrow you will be in the planning level. Then how we will choose the contractors? You have to find the reports from the field.
Sir, if the remaining contractors are not eligible to supply the or do the work,
then you have to tell them, you have to go to the details that your supply 92 materials are there.
No, maybe their supply is higher. They are supplying also 80% of our supply is from that contractor only. That case, if we remove that, then our supply will be only 20%. Maybe these failures are related to the supply of the quantity.
No, you then take percentage of it. Suppose he is supplying a higher quantity. You take percentage of defect, not number of defect. You take percentage of it, that you are supplying these things, but your 93% of your thing is bad, not useful. So you categorize them at that level. And how it can be done? Actually, it is not useful. It may not be at present useful to your field, because you are not at that position. Suppose maybe, but maybe in tomorrow you will be in a position to choose contractors, or you will be in the planning level. And moreover, this is total quality management is related to all employees. So your planner, your policymakers must entangle yourself. If you are reporting this kind of things, but if they are not looking into it, then there will be no total TQM. It is simple and straight. TQM only, therefore I am going to the philosophical part. It must entangle everybody. It should be a philosophy of everybody entangled in the department. It is not only one work or one job to do. Actually, we are doing things in the field, we are doing things job by job. We are doing this job, yes, okay. We are doing that job, yes, okay. But we are not relating it. You are not interconnecting them. Therefore there is no quality in many cases. Therefore many failures are there. Therefore breaches of dams and erosion controls are not useful. Why it is so? And these are perfect things, ideal things. You cannot do it ideally, but you can apply it. You can try it if the department is interested in it. If the whole department is not interested, or no people is interested, in the field level people is not interested, and there is the thing like change management. If somebody is not interested, how will change it? If our field level workers are not interested to this, how will change it? How will change the mindset? So in management sciences, there is a important aspect, that change management. How will make the change? You must change it. Otherwise, how there will be success? So this is related to not related to only one job. This is related to the whole department and whole concept. So now, do you think not contractors in any other field? In any other field, you can apply Pareto search. Do you think in any other cases you can do Pareto search? To filter out. That means what is this? To filter out the most problematic area. Most problematic part, you have to filter it out. Suppose you are doing a field work. You are engaging 10 persons there. 10 persons. You are engaging people. Is not it? So 10 persons you are engaging. So what are the good worker? You have to filter out the bad workers. How you will do it? How you will do it? You can use Pareto search. Is not it? No? Yes or no? To filter out the bad workers, you can use Pareto search because you see how much fault he has done, how much work he is not doing. So these are actually these are high quality management thoughts. It is applied mostly in modern day management industries.
80-20 rule are some hypothesis or practically
It is practically possible. Practically possible in any case. In any case,
lot of sample has been studied.
yes, lot of sample has been studied. Yes, you just in Google you search Pareto search or Pareto analysis. You will get. But my point is that it is there. It is like universal law. But you see, we are also manager or worker in a huge department. Are we using it? So you think it is important or not? Actually, scientific calculations and measurements are important. So we measure. I am also from a department where many practical things are there, but scientific measurements were not there. So scientific measurement is very important. So these are quality measurement scientifically how you can do. These are the tools. A simple check sheet I have shown. It can do a great work for your planning, for your determination, for your decision making. But we are making decision making by assumption, mostly by probability. So these are the finer things, I think. This is Pareto search. This is failure mode effect analysis. It is another very important and effective tool, FMEA, of total quality management. And it can be used in design, planning, implementation, inspection, everywhere. Everywhere. What is FMEA? What is FMEA? Let us understand some point about it. There are two parties. One is failure mode and another is effect analysis. Failure mode means how a failure can occur, and another is determining what effect can be there due to this failure mode. So you see how will you use in your case. So FMEA is also a very important concept. I am going to this. Hmm? 1 minute. This one. There will be a practical example on this. You just see. There will be a practical example. So these are FMEA steps. FMEA, failure mode effect analysis. These are the steps. First, review the design. You are doing some design. First, review the design. Use a blueprint or design product to identify its components and interface. Second, brainstorm potential failure modes. What failures, what kind of failures can be there with related to the design? And then step 3, what effect can arise due to this failure? You have to record it. And then step 4, you have to assign three dimensions. Severity. Severity means how much severe is the failure. How much severe is the failure. Secondly, you have to determine how many times it can occur. How many times it can occur. Then you have to determine how we can detect it, the failure. These 3 things you have to assign. Then you have to calculate 1 RPM. That means severity, that is the application, that is the product of severity, occurrence and detection. And after that, you have to take action on the failure. So this is the theory behind this. So we will go to the practical example. Okay. This is a practical FMEA example. This is suppose this is a component or design. Your component or design is this. Potential failure, what kind of failure may happen to this design? These are this. And potential failure effect, what kind of effect may be there in your work? These are this listed. What effect can it do on the field stuff? These are the list. Potential causes of failure. What are the causes? What are the causes? Causes of this failure is, you have to record this. Detection method. How we have detected the failure? You can record here. Then O is the occurrence. S is the severity. D is the detectability. And this is your multiplication of these 3 is 192 or like this. So this is a FMEA chart. Now you see one by one. Control cable. Control cable is the product. Wire damage broken. This is a failure mode. Wire damage broken or damaged. This is failure mode. What can be the source? Source cannot be projected. Source we cannot say, suppose maybe we cannot say. Failure occurs on persons. Potential. What kind of effect can it impart to your person, your field staff. Potential exposure to occupational workers will be there. Then potential causes of failure. What can be the cause? It is maybe wear and tear. And detection method, inspection. How you have detected it? By inspection I have detected. What is the occurrence? Occurrence. These are the ranking. This is the risk scale. So occurrence is 1 to 10. 10 is most likely. How many times it can occur? You have to determine it. Suppose you are determining that control cable wire damage failure can occur 3 times out of 10. Out of 10. It is upon your observation. Then it is 3. Suppose severity, how much severe it can be. 10 is the most severe. How severe the failure can be. It can be most severe than it is 8. And detectability. Can it be detected, this failure? Can it be detected easily? If it is least detectable, then it's difficult to detect, then you have to give 10 or 9 or like this. So suppose you are giving it 8, it is not easily detectable. Then the product is 192. This product comes to be 192. Then suppose this is another failure. Male coupler dimensions worn out. Coupler dimensions worn out. These are additional items you can use in your quality management. But you are getting 2 here occurrence. 2 times out of 10 it can happen, so it is 2. And this ranking severity ranking is 9. And detectability it is 3 suppose. Then the product is coming 54. So like this, related to the control cable, every failure mode, what kind of failure may happen, you can know. And how it has happened, you can know. How many times it has happened, you can note it down. How much severe it can be, you can note it down. How much detectable, how detectable it is, you can note it down. Then you will get these 3 figures. Suppose out of these 3 figures, you are getting that 192 is the most risky. Because this is coming to be 192, and therefore you have to address this first. In the ranking, there are these charts are longer actually. So in the ranking, it will come first. This is second. This is third. So as a manager, you have to remove this first. Wire damage and broken. This is your most difficult problem. That means in any design or in any construction, in any cases of erosion like this, what are the failure modes? And you determine this. After that, you can say that your first action will be this, to remove this, address this, then this and then this. Because you see, in suppose in any problem, in case of any dam, there are many problems there occurring there. Which is important? Which is to address first? How can you determine? Do you have a tool? Do you have a tool to determine what is the most difficult problem? We only say by our mind that this is most difficult. This is not so difficult. But why? What is the reason? So the scientific reason may be here. And the science is in your hand, because you can determine this severity, you can determine this. What are the things? When you call it severe, when you will call it not severe, when you call it detectable, when you will call it not detectable. It depends upon the manager. So if you know this, then you can apply this. Now, how many times it can occur? This is the probability of occurrence. You also know that as a field manager, such cases are happening out of 10, out of 10, 3 times it is happening, 2 times it is happening. As a manager, it is in your mind. So by doing this, you can categorize the failures and address these failures. So can you now say that in which case in your field you can apply this? Failure mode effect analysis. This is failure mode, this is effect analysis. And again, this is a long term because here action recommended. What action you are recommending? Based upon this, what action you are recommending? Yes, I am recommending periodic quality testing. Periodic quality testing. I am recommending this. Yes, you recommend anything here? And then again you make after some time. Again you make your FMEA start. Then again you will detect the RPM. Okay. Then you can determine which problem is, and in this case I have given the additional text. It is in a group. There more details are there because it is not possible to tell everything here. So there it is. If you are interested, if you want to apply this science to your work, then you can find it out. I am only telling you that in the world it is developing like this nowadays. It has gone beyond our imagination. We are doing many things by our mind only, which does not have any scientific base, only by thoughts. But big companies, big industries, they are not doing like this. They are using this TQM, they are using this check chart, this tree diagram, anything, wherever it is applicable. And another important thing for our employees is that what is applicable to your job? You have to think it out. You have to think it out. And also your senior managers or senior persons may tell you that you use this or use this or use this. But I think you will also be in the senior position after some time. So the knowledge is important, I think. So another very important technique. It is also simple. It is like a very simple. This is 5 whys. 5 whys. It is applied by managers in big companies. 5 whys. It is interesting. You will say that it is nothing. It is nothing. It is nothing, but it is scientific. You see, investigative techniques to find the root cause of problems that do not require quantitative analysis. Suppose there is a problem, you do not have any quantitative data. In the failure, you have got quantitative data. This much failure has occurred. These suppliers are supplying defective material. You have quantitative data. 2 bags, 3 bags, 4 bags like this. 1 truck, 2 truck like this. There is quantitative data, but here is no quantitative data. But difficulty is there. Quality management should be there. But how you can do? So it is very simple. Keep asking why. To trace back to the source of failure. Example, why did the retaining wall collapse? Poor material. Why were poor materials used? Supplier issue. Why did supplier issue occur? Lack of quality checks. Then asking this why, asking 5 whys, you will detect that this is the problem. Otherwise, you cannot detect what is the problem. Whenever you report it, suppose there is a problem, you have to report it. You have to ask this why. Then you will get the answer. And this answer will be in your report. So asking this question, you can eventually get to a point where you see a possible way to resolve a problem. This is a 5 why. Then Ishikawa fishbone diagram, this is also applied like this. This can be applicable. Do you think it is applicable? In some way, do you think it is applicable to you? Do anybody think it is applicable? Yes. Very good. How can you elaborate? How? In which problem? You are thinking about some problem, suppose. In which problem? Please share with us. In which problem? In which problem or in your field you can use this?
Suppose that there is a glitch in management.
Yes.
So failure.
Yes, correct.
You can draw.
Yes, correct. 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 Then your causes, category of causes will be, you can select it. These are the category of causes. It can be due to the people. It may be due to the process. It may be due to the equipment you use.
Poor material.
Poor material. It can be due to environment. Suppose flood or anything, environment or like this. It can be due to management. And in this also, these sub-branches are very important. These sub-branches. In case of materials, what kind of things sub-materials? This may be one, this may be another, this may be one, this may be another. Like this. So you can find out the sub causes, then you can eliminate it. If you treat the problem, want to treat the problem, then you have to eliminate them one by one. Therefore, this fishbone diagram will lead to the solution of the problem. But this kind of listing, this kind of determining things, I don't think it is here now at present. At present, do you have any tools like this to determine the different cases? Different, huh? Checklist you have, yes. Checklist you have, yes. Checklist is used. Checklist is used. Yes.
In this case, we have to go through all the aspects of suppose equipment, process, and management, and then pressure. After that, some if the problem will be come out.
Come on. Yes.
So what is the major problem?
What is the major problem? Measure, you can determine what is the measure problem. Suppose maybe this may be 0, this may be 0, this may be 0.
Suppose if that suppose if the management there is management, so suppose 5 numbers will be okay, and the management will be the measure causes.
Maybe. So this is a scientific analysis. This is a scientific decision making. It will lead to scientific decision making. If somebody asks you how you have taken this decision, you should show them this is my decision making tool. So investigating, here is an example, investigating causes of cracks in concrete structures due to workmanship, materials and weather conditions. What is the reason? So you can determine by this. So another tool is fault tree analysis. Fault tree analysis. It is also like this, because our problems are interconnected. One problem gives rise to another problem. So in fault tree analysis, it's a graphical method to analyze failures. What causes this failure? One by one, you can analyze this. This is called fault tree analysis. Example. The example is not from flood and erosion. It is from different industry. Then another tool is 8D report template checklist. 8D report template checklist. 8-step approach for structured problem solving helps ensure corrective and preventive measures, ideally to complete within 8 days. Suppose you have to go to the field and report about a failure. Report about a failure. You are given 8 days or 10 days. In 8 days, you can do this by applying these principles. What you will do? You are going to inspect that. What you will do? What you will do first? What you will do second? How you will give the report? These are the structured steps. So I think the knowledge of these things are helping people to work better in any project. You see, the first thing is establish a team. To deal in the first day, you go there to the site, you establish a team. 2-person, 3-person, or number of persons may be there. You establish a team. Then define the problem. What is your problem? You define it. What is the actual problem, exact problem? Then contain any problem that arises. The team focus on containing the problem without affecting daily business operations. The goal to minimize the impact of a problem and avoid chain reaction. Then find the root cause. And in finding the root cause, you can use fishbone diagram. In finding the root cause, you can use Pareto chart. Anything. So this is also a procedure to improve our work. In there, you can use checklist also. Anything. Till now, suppose you are using checklist and you know about checklist. But after that, if you know about the Pareto chart, you can use Pareto chart. You can use fishbone diagram. You can use anything, any tools. Okay, this is 8D report template checklist. This is the make template. This is another template. This is called the make template. The make template. Here is an example: strengthening embankment to withstand floods by analyzing soil stability and making necessary improvements. The picture shows you that D means define problem, M means measure, A means analyze, I means improve, C means control. So these are the scientific steps. You have got the problem, you have heard about the problem, you define it first. Definition is most important. Definition is. Mostly in our life, we are not defining things. Why we fail? Why we fail in many cases? The reason is we are not defining. Why a student is not pursuing a good career? You can find out that he is not defining. From the definition, it is wrong. Okay, so definition of the problem is very important. And for that definition, previously I have discussed about brainstorming. You should brainstorming discussion to arrive at a problem definition. Because it is not by you cannot make it by one person's thought. You can discuss it with others. Then find out the problem and then define it. What is the problem exactly? Then measure it, measurability, measure it, measure baseline performance. Measurability is another important thing. Can you measure it? One scientist, you have heard about Lord Kelvin scale, Kelvin temperature scale is there. Okay, 273 degree Kelvin. The Kelvin is a scientist and a philosopher. He told that anything you cannot measure, you cannot tell any scientific thing regarding that. If there is anything you cannot measure, you cannot take a scientific point of view regarding that. That means almost we do not have any knowledge if you cannot measure it. Only when you can measure it, you can say that yes, I have some scientific knowledge about this. So in any case, in our life also, measurability is important. You can measure it or not. If measurability is not there, if you cannot measure, then try to determine a scale to measure it. And here the TQM gurus are trying that. They are trying to measure. They are trying to measure the failures. They are trying to measure by Pareto chart. They are trying to measure something. So measuring is their goal, first goal. And after true measurement, you can take action. So this is define your problem. This is measure. Then when you measure it, then you will get some data. Then you can analyze it. You can analyze it. And then if you can analyze it, you can improve it. Okay? And then if you can improve, then you can control it. And for any manager, in any field, the control is the main thing. Whether as a supervisor or as a worker or as a manager, you have the control or not. How can you control? If you cannot define, if you cannot measure, if you cannot analyze, if you cannot improve, then you cannot control. So everything lies in this philosophy actually, I think. So they are actually TQM gurus, they are going to these philosophies of life. How things can be most scientific, which looks non-scientific. So this is important. So that is why it is called a philosophy. Scientific interpretation of whatever is going on around us. DMake template. Then and scatter diagram. Scatter diagram also tells us a important scatter diagram. Have you used scatter diagram? It is also very useful. Because suppose two things are there. Example, studying the correlation between soil erosion rate and rainfall intensity to predict future risk. Suppose there are soil erosion. Suppose there are rain intensity. These are two variables. These are two variables. How they are related? How they related? Somebody may say that the erosion rate may be related to rainfall intensity. But is it scientific? Question is it scientific?
Yes.
How can you say? But
if there is more rainfall, then we flood situation possible.
But actually, it is just observation. It's just observation. So we can say that observation in certain things are easy, but observation in many things are not easy. You cannot determine. Suppose internal stress or internal difficulties or internal damages, things like this, you can see. Then you have to see how the variables are moving. How the variables are moving. If one variable is increasing and then another also increasing, then you can say that yes, they are related. But if one variable is increasing but other is decreasing, then you can say that no, these are not related. There may be some different cause. And if you get a chart like this, last one, you can say that the two variables are not related. Then, if you see, suppose you plot soil erosion rate and rainfall intensity, soil erosion rate and rainfall intensity. If you get this kind of chart, go away from your assumption. If you get this kind of chart, you have to say that there is no correlation in this two. And it will be true. There is if you get this kind of chart. This is scientific. This is scientific. But we assume that the rainfall intensity is affecting erosion. It is not science based. So this is a practical use. And another important thing in total quality management is it is it is okay.